Hi friends, welcome to the lecture series on MOSFET. So what is MOSFET? MOSFET is metal oxide. Let us write MOSFET clearly. It is metal oxide semiconductor field effect transistor. Field effect transistor. It is called MOSFET, right? So there are two types of MOSFET. One is, we can write like this. We are having two types. One, I call it as, let us write enhancement MOSFET. Second one is depletion MOSFET. So enhancement MOSFET, simply I write as EMOS. Depletion MOSFET I write as DMOS. So there are two types of MOSFET. There are two types of channels. So according to the channel types, we are dividing MOSFET into two types. One is N channel and P channel. Similarly, here in DMOS we have two types. One is N channel DMOS and P channel DMOS. So totally four different kinds of MOSFETs are available, right? So N channel EMOS, P channel EMOS, N channel PMOS, N channel DMOS and P channel DMOS. So in MOSFET simply we have two types, two channels. So we are having totally four combinations, right? So that is very important point. So next, in MOSFET we are having four terminals. So MOS is a four terminal device. MOS is a four terminal device. Right? Okay. So what are those terminals? Let us see. So here you see we are having four terminals. One is source, second one is gate, third one is drain, and the fourth one is substrate, or other name for substrate is body. So MOS is a four terminal device. So those terminals are given here. So we have studied four different kinds of MOSFET. No? So here you see this is P channel. So it is P channel. If it is a depletion MOSFET, because in depletion MOSFET we are having channel initially. So from the structure itself we can identify whether it is a P channel or N channel MOSFET. So without applying any voltage, we are having the channel between the source and the drain. So it is simply P channel, right? Depletion MOSFET. Channel is P, that is given here, and initially channel is available, so it is a depletion MOSFET. Here you see channel is N, and it is available initially, so N channel depletion. N channel depletion MOS. Right? Okay. Here we see, here there is no channel initially. Right? So if there is no channel, it is enhancement MOS. Enhancement MOS. So here you see source and drain are N-type, so they will be N-type enhancement MOS. Simply you can say NMOS. Right, so here you see there is no channel, so surely initially no channel, so it is enhancement EMOS, and the source and drain are P-type, so we can say P channel enhancement MOSFET. So in enhancement MOSFET, we must know enhancement MOSFET are simply EMOS, initially no channel. right? So that is a very important point. Whereas in DMOS, channel is available at the start. Channel is available initially. Right, so from that we can identify whether the MOSFET is PMOS or DMOS. From the channel we can identify. In PMOS, in enhanced depletion MOSFET, we can find from the diagram itself, they will say it is P channel or N channel. In enhancement MOS, you see the terminals, what are the semiconductor used in source and drain, so it is N, so surely the MOSFET will be NMOS. From source and drain terminal, we can identify, especially source terminal, we can identify whether it is NMOS or PMOS. Here source terminal is N type, so it is NMOS. Here source terminal is P type, so here you see it is PMOS. It is PMOS and no channel initially, so it is enhancement type PMOS. Here no channel, so enhancement type, source is N type, so NMOS. So like that we can identify the MOSFET type. So we will analyze the structure in detail in the next video. It is introduction class only. Okay, so what we understood, simply I write again, MOSFET is a 4-terminal device. First thing we have to know that, right, those terminals are source. What source will do? Source will inject carriers, inject charge carriers, right? That is a function of source. Second one is drain. What drain will do? Drain will absorb charge carriers. And third terminal is gate terminal. It is controlled terminal. Right, so it is control terminal. Let us see what it will do in the structure in detail. Right, so there is a point, that is it generates electric field to control current flow. Where current flows in MOSFET current flows between source and drain. So that is the important point, right? So those are all the points we have to know. Fourth one is substrate or body. Okay, so this thing we have to know. Next, what we have to know about in MOSFET is, it is called field effect transistor. Why it is called field effect? So you must know what is field effect, right? So here you see, here we are, the current is controlled. Here what we are doing is, right, by applying electric field, perpendicular to the semiconductor, perpendicular to both semiconductor and current direction, the current flow is controlled. Current flow is controlled in MOSFET, right? So here we are using the electric field to control the current direction. Where we are applying the current electric field is applied perpendicular to both semiconductor. We have seen the body is a semiconductor and the current direction. Okay, so we will understand what is field effect, the modulation, the phenomenon, or we can say that the phenomena used to change or control the current in a semiconductor by applying electric field perpendicular to the surface. by applying electric field perpendicular surface is called field effect. So that's why it is called field effect transistor. So here electric field plays very important role. So simply what is happening here is the main principle of MOSFET operation is voltage between two terminals control the current through the third terminal. Current through the third terminal. So here where we apply the voltage, right? So here we apply gate voltage, and it is controlling the current flowing through the drain and the source. That's what the main principle behind the MOSFET. So you can ask how field comes here. We know E is equal to minus del V, right? So electric field and potential are perpendicular to each other. That's what we are studying here, right? So when V changes, electric field will vary. This electric field controls the current flow. When V changes, E will change it. So this change in V will control the current flow. So this is the principle we are using in the MOSFET, right? So we will analyze everything in the MOSFET structure and character, right? Okay, now we will see the circuit symbol. So for N channel EMOS, let me draw the circuit symbol. So you see in enhancement MOSFET there is no channel initially. So we are having three terminals. So this is given by no channel. The gap is indicating no channel. Drain, source, gate. So here it is body B. So this is conventional symbol, but simplified symbol we use in the subject is this is N channel MOSFET, right? So drain, source, gate. So the arrow mark will be in source, please remember. So this is plus VGS, here VDS. This is N channel enhancement. This is circuit symbol we will use. Okay. So similarly for P channel, the conventional symbol is like this. Drain, gate, drain, gate, source, drain, body. It is like this. This is conventional symbol. Circuit symbol is always source. The source as arrow mark. Source, drain, gate. So it is VSD. This is VSG. So this symbol is used in the problem solving technique. So this is very important, right? So here also you must remember the symbol and terminals, right? Polarity. This is N channel and this is P channel enhancement MOS, right? Next we will see the circuit symbol for depletion MOS. Okay. So for first one, we will draw the circuit symbol for N channel depletion MOS. This is depletion MOS. We know initially there will be a channel. So D, G, S. So channel means you join it. Okay, so it is VGS N channel This is circuit symbol, conventional symbol, right? Here plus minus VDS. Circuit symbol is like this. Body, I forgot to put body. Body is like this. For N channel, D, gate, source, here VDS, here VGS. It is N channel depletion MOSFET. Okay, here we have channel, so that is given by some channel. So this is channel. So we can relate. This is channel. Similarly, for P channel depletion MOSFET, source, drain, gate, body. This is conventional symbol. This is circuit symbol. Gate, source, drain. This is ESD, right? And this is ESG, right? So this polarity is very important. This is used in the problem solving technique, right? So these are the symbols of MOSFET. So another thing we have to remember about MOSFET is it is a symmetrical device. MOSFET is a symmetrical device. Why it is called a symmetrical device? So we must know that in MOSFET, drain and source terminal can be interchanged, whereas that is not possible in BJT. Hope you have seen here. Here we can see that. So this is source terminal, this is drain terminal. Instead of this is a source, we can consider as a drain. Here we can consider as a source. That is, interchanging of source and drain is possible in MOSFET. But in BJT we cannot interchange emitter and collector. So that's why MOSFET is called a symmetrical device, right? So source and drain can be interchanged. That's why MOSFET is called what you call symmetric device, and it is a voltage controlled current source. Voltage controlled current source, right? So the current which is controlled, the current, drain current is a function of gate to source voltage. That is, voltage controls the current. That's why it is called voltage control current source. By varying the gate voltage with respect to source, the current flow between the source and drain is controlled. That's why it is called voltage controlled current source. And in MOSFET, current is it is a unipolar device. So current flow due to only one carrier. We are staying N channel and P channel, that we will see later in detail. So current due to only one charge, current due to only one carrier, that is majority carrier, right? So that's why it is called a unipolar device, right? So this is another important point, right? So these are, and another very important point is input impedance of MOS is very high. Okay, so that is another point we should remember. MOSFET has very high input impedance, right? And the advantage of MOSFET, that is another very important things. The first advantage is Zn is high, right? What is the advantage of high input impedance? That we will see during the course. Second one is noise immunity of MOSFET is high compared to BJT. Third point, right, high packing density. So within a small area, many devices can be packed. So that's why MOSFET is widely used in the IC, therefore used in IC widely in integrated circuits. And MOSFET is faster. Okay, and it consumes very less power. Consumes very less power. That is another advantage of MOSFET. And the last one is scaling of the device is possible. Scaling, we can increase, right? So increase the MOSFET. That and all we will see in the course, right? So scaling of MOSFET is possible. So the main application, whatever we do in handheld device, right? Handheld calculator, right? Handheld calculator, laptop, everything is possible because of the MOSFET, right? So all the handheld devices are possible because of the technology of MOSFET, right? So that's all about this session. Thank you.